What is up, guys? DevCode here. So, I want to get a couple things straight. In the past month, I've been spending quite a bit of time really thinking about my programming language that I've been developing, and that's kind of why I haven't been putting out any videos. And I was also thinking about where this channel is going to go going forward. So, in this video, I'm going to get a couple things straight and maybe answer some of you guys' questions if you've had any. And as you can see, if there are pauses in my speech or if I say or something, this video isn't going to be edited. I'm just going to give it to you guys straight because it's going to be quite a long video. So, if you couldn't tell by my title, we're going to be talking about a new programming language. Now, it's an object-oriented programming language. And before we get into any of that, I want to kind of explain a little bit about myself and what do I do and why I'm kind of doing this. So first, I'm an Android developer. That's my main profession. I've been doing that for about 4 years now professionally. And I also do .NET and I know SQL. And I do some C++ programming, but it's mostly on the side, and some other languages as well. I've been programming since I've been 16 years old, so I have a lot of knowledge when it comes to just programming in general, multiple different paradigms, using Python, and so on. So why are we kind of doing this, right? So I like Java, and C#'s nice, but I really think that they've missed the mark when it comes to object-oriented programming and what it should actually be. Because I feel that Java and C++ really force the concept on you of this is an object-oriented programming language. You need to be object-oriented. You can't really do it any other way. Now, I know Java has recently kind of been opening up in the past few updates. With the recent update, Java started adding functional programming, so you can create lambdas and stuff like that. But at its core, I feel that Java and C++ conceptually are just trying too hard when it comes to the concept of object-oriented programming. So the first question you'd probably ask is, well, why should we consider my language? Well, in order to answer that, it's not just your typical object-oriented programming language. Sharp is a programming language that allows you to be and express the object-oriented paradigm, but it doesn't force it on you like Java and C# does. And something I kind of always say to me and some of my colleagues that I work at work is, object-oriented programming is a tool, but it shouldn't be a constraint in terms of what you program in and how you program your code. Because whenever you have to code in Java, you have to think about, okay, so I have this object and it's supposed to perform some task, but wait, I need to do something else. Okay, but now I need to create another object to do that task. And okay, wait, but now I need to have these objects be in sync so that way, I keep the states managed within each individual object. And, I don't want to have them messing with each other. So I have to create these private methods to kind of do everything. It gets really messy, especially when you have a really big application that does all different types of things. It just makes conceptually thinking about object-oriented programming and making your applications in Java very complicated and unnecessarily complicated, which slows down your development time and also slows down the time that it's going to take for you to bring your application to production. But as with everything, there's a caveat. So speed is always the number one thing. I know nowadays computers aren't really getting that much faster. We've kind of started to get into the area of Moore's Law. When is it going to end? Nobody really knows, but we're getting pretty close, as some experts have said. And speed still is a concern. I mean, our computers are pretty fast, but nowadays people are more so caring about the usability and the practicality of the actual language versus speed. So that's why people love Python so much, because it's just so much easier to do everything than to create a Java application, have to create all these objects and have them use each other in some majestic way. And if you inherit something in the wrong way or something like that, you can break things. So that's kind of why in my opinion at least, why people have been kind of flocking towards Python. And when it comes to speed, it's always a trade-off. And with every language, there obviously has to be some trade-offs, but I kind of just don't like how language have been languages have been designed in general to act in such a way where if you have an interpreted language or object-oriented programming language, it's going to be garbage collected, which, number one, slows down your overall execution of your program, because if you're allocating thousands, hundreds of thousands, or even millions of objects and dumping them and creating new ones, that's really going to impact performance. And then also, you're forced to use the object-oriented style of design, like I said before. I don't really like the Java and C# kind of forces that on you. I kind of like Python, where you can have a class, but you don't have to use a class because it's not really necessary. You don't have to use classes aren't meant for everything, because everything doesn't need to be that much constrained. Also, you have the problem of it being really slow. Now, I know Java's gotten a lot faster over the years with their JIT and stuff like that, but a perfect example would be a language like Python. And Python is an interpreted language, so by definition, interpreted languages are always going to be slower than compiled. And then you have the other hand, where it's really fast, but wait. What if you have some object that's a structure and you pass it to some function, but that object has a constructor? First of all, you have to create the constructor to construct the object. Then you have to have copy constructors, so that way you can make sure that all the data is being processed and you're giving all the pointers to the right addresses and stuff like that. And then you also have to make a destructor to make sure you're not leaking any memory whenever the object gets out of scope. But then but what happens if the object that you pass into that function thinks that it owns the pointer, but then the destructor gets called on the object before the copy constructor, and now you're using freed memory that's pointing to an invalid heap? There's a bunch of just crazy things that happen when it comes to C++, and the thing that I don't like is that you always have this topsy-turvy kind of thing where, okay, you get a bunch of benefits in programming, great. You can do all this really cool stuff like in Python. It's really easy to understand, but it's very slow. On the other hand, you have something that's extremely fast, but it's such a pain in the butt to get working, and the learning curve is also much higher. And then you also have to use this crazy syntax to get anything remotely high-level done in languages like C++ and C. But we also forgot to talk about double freeing. So I hate double freeing. That's another problem with low-level programming languages. So the benefit that object-oriented programming languages and higher-level languages provide is that you don't really have to worry about memory management. That's nice, but because of that speed aspect, it kind of really hinders you when you need to have some really speed-critical application like a game or something like that. And you have to deal with all these double freeing errors and making sure that you call malloc and free in the right way. And C++ also has this thing where if you call malloc and then you call the delete keyword, so you delete an actual pointer using the delete keyword instead of using the free, there's this thing where it just breaks and stuff like that. So it's just a really big pain in the butt, and I kind of don't like how we've kind of been really going in this direction for a long time. And I understand, because it's very hard to make a language handle both of these worlds in a very intuitive and nice way, and that's where Sharp comes in. So memory and speed are how that's kind of my main concern about this language. And of course, I have some other things that are going to be added later on. But whenever you program, you have to think about, whenever you're building a new programming language, what is the thing that is going to benefit the users the most? And typically in programming, we spend most of our time allocating memory. We spend most of our time worrying about how are we allocating our memory? Are we allocating too much? And are we leaking any memory? How are we passing the data around? So on and so forth. So memory and, of course, speed also. You also care about what's the speed of your application. Where are the bottlenecks? Trying to find those bottlenecks and, make them faster. So those two are my main concerns with this programming language, with other benefits with it as well. So what is Sharp, right? Sharp is an object-oriented programming language, but it's a greatly less restrictive language than C# and Java. And the benefits, you basically get the best of both worlds. That's kind of where I've gotten this whole concept of Sharp from. I wanted to take the main languages that I use the most in my professional career and, doing some side projects. I use Java because I do Android, and I do a lot of C# because I used to do .NET. So I took those two, and then I also took Python, and I kind of put them all in one language. And the benefit of this is that you will have, of course, the object-oriented approach for the programming language paradigm, but you also have a functional programming language paradigm in the language, because I get that from the Python style of the language. So you don't have to always work off classes. You can do strictly functions if you want. I actually created a game in Sharp where I only use functions. It was a snake game, and I never resulted to using objects because I didn't have to, and that was kind of really nice. But you also have a procedural programming language paradigm, and what that is Sharp allows you to do some assembly coding. Now I'm going to go over that a little bit later on. That's not really important for the topic right now of this video. I kind of just want to tell you about the language, introduce it, and get it out there so that people can start to see this language and the benefits that it provides. So I also want to expose the underlying mechanisms of the actual system that you can use. So like, let's say you wanted to create an integer array and you wanted to copy that. Well, the only way you'd be able to copy that at a high level is you'd have to create a for loop or some for each statement and iterate through that, and then take those elements and then copy it to some other object. But I actually wanted to have the user to be able to do that, but also to be able to have the benefit of having C++ level of performance when it comes to memory copying, and you can just do a literal system.memory copy and copy the actual memory from one array to another, and it's completely safe. You don't have to worry about messing with any pointers or doing anything scary like that. Another benefit that it offers is garbage collection. So I know there are probably going to be some of you out there that's going to say garbage collection sucks. It's probably a stupid idea of why I'm implementing garbage collection in my programming language. But the thing about Sharp is that it doesn't force garbage collection on you. So garbage collection is really annoying. I've built multiple applications where garbage collection has gotten in the way, so I offer optional garbage collection. But the way that I do it is quite different from the way that I know that programming language D offers optional garbage collection. So one could argue, well, I can just use D language because it offers, some optional garbage collection. You see, I'm making tons of mistakes. So all of you comment trolls out there, you can save your comments. I know this is unedited, so not really pointing anything obvious out. But in Sharp, we're going to have what's called self-garbage collection and manual memory management. So you can do your own memory management, you can do malloc and free, and we're going to get into a little bit later on, the constructs of malloc and free, because everybody knows that in C++, malloc and free, depending on how you use it, could be very, very dirty, and, so there's some other stuff to it that I'm not going to get into for the purposes of this video, but I'm sure you would know where I'd be going with that. And then also, another reason to use Sharp is that the problem that I've mentioned before is that even though Java's gotten a lot faster, and I can't really speak for the speed of C#, but I assume it's somewhere in the realm of Java, maybe faster. But the main purpose was that, okay, I have this cool language that can offer multiple different paradigms, but most likely what's going to end up happening is that it's going to be a really slow language, because you have these high-level constructs and ideas about how to program, and then you have to translate that down into the computer, and it's really hard to do that from high level down to low level. So most likely I would make some type of interpreter. Yes, Sharp is interpreted, but it has a JIT, and with my JIT I've actually seen near C++ level of performance, which we'll get into later. So I'm going to do some further explaining. So languages that are garbage collected usually force you to bend to the wheel of the garbage collector. So I don't really like that. Basically, if you create some type of application in Java and you're allocating all these objects and you're freeing them up, or even in Python would be a better example. Python really struggles with garbage collection. Whenever you allocate a bunch of objects and free them up and now they have no more references, depending on how many of those objects you free up, in the certain span of time will depend on, how slow your application goes. And of course, that is a problem with my language as well. But what I'm getting at is that even though D provides optional garbage collection, I feel that D is kind of like a better version of C++. But to be honest, I really don't want to use C++. It's nice to have a language that has optional garbage collection. But when you start getting into D really trying to be like a much better C++, I don't really like C++. I kind of want to run as far away from that as possible, but still kind of get the same benefits that you get from C++ in a much safer option. So maybe you could say that my language, oh, well, you're just like Rust. Rust kind of emphasizes this like idea that, you have pointers, but we want to make sure that it's really, really safe, that you don't do anything dirty or nasty. And of course, you can have a unsafe block where you can do some unsafe stuff with pointers. But again, I kind of don't want to be that low level of C++. It's nice to be able to go there when I need to, but for the most part, I want to kind of stay as high level as possible. So you shouldn't be burdened with the need to perform your own memory management. If you haven't gotten that already, I really hate the fact that garbage collectors do that. Now, garbage collectors have their own place. Like if you have an application, you don't want to do your own memory management. In certain situations, a garbage collector is actually very helpful and it's very convenient to have. But what if there was a better way than to have to always depend on this garbage collector and, worry about doing your memory management? Because the way that it works right now is that you either have a language where it has a garbage collector and you have no choice but to accept that it has that and use it, or B, you have a language that is optional with garbage collection, but then now you have to do your own memory management, which is kind of a pain in the butt depending on what you're doing. In some cases, though, it may have its benefits. But what if there was a better way? So I wrote up this simple program, and again, it's very trivial, but I just want to kind of express the usages or the use case of my language when it comes to making garbage collection and memory management a lot better. So let's say we have, some function, and you don't have to worry about what everything does here. That's not the important thing. What's important is that we have some variable that, allocates some huge array, and then we iterate through that variable, so for n, whatever the variable is, and we do some calculation with that. Maybe we can pass in, some data to that function or do something else. So we do something like that, but then once we're done with it, how do we free it? So of course, if we just want to depend on the garbage collector, if we try to allocate another one of these immediately after we do this for loop, we could potentially have an out of memory error. Sorry. And that's bad. And of course, you could probably say, well, what if you just ask the garbage collector to collect? Well, that doesn't always happen, depending on what the garbage collector is doing and depending on how recently it just ran a collection. You know that whenever you hint to the garbage collector to do a collection, it never happens. So of course you could say, okay, well, you could just do your own freeing through what I said before, do a malloc on this variable and then do a free afterwards. But what if there was even a better way than that? So you can kind of see here that I have a simple if statement that says if we have any free memory and our free memory is less than 5 megabytes, then we want to do something with that. So in this example, it's a little bit silly how I've kind of done this, but bear with me a little bit here. So first, we say some data is equal to null, so we dereference it. Now, right below that, we could try to call the garbage collector and say collect, but more times than not, unless you get really, really lucky, it's not going to collect it immediately when you call it. So you could argue that, okay, we can just say free. Well, that's one thing, but if you don't want to do that, an even better way is that you can see here that we've already set some data to null. So one benefit to Sharp is that if you free something that's null, you don't have to really worry about double freeing it. You don't have to worry about this still holding a reference or something like that because it's already set to null, so nothing will happen. But then now this memory is leaked. So the free didn't run and we set it to null, but this variable here or this integer array is still sitting somewhere in RAM. So how do we do that? Well, we could do something that's called collect. And what that does is that's doing what I stated earlier on, which was self-garbage collection. So what that does is, you can see up here we have sedate. Basically what that does is that puts the garbage collector to sleep. So you can do one of two things in Sharp. You can put the garbage collector to sleep, or you can actually kill the garbage collector and just say, no, I want to do my own memory management. In this case, I just put it to sleep. And whenever you call the collection function on a garbage collector that is asleep, what happens is you run through the entire heap and you clear out any leaked memory that is just sitting in the heap that has no references, that you can't access and that you can't free. So if you've accidentally freed up or set some data to null and you have some huge memory that's sitting out in the heap, you can call collect and it's going to just take care of that for you. So you're essentially sitting yourself in the driver's seat of the garbage collector, and you're performing the operation that the garbage collector will be doing behind the scenes. And I don't want this video to drag on too long, so I'm not going to go too much into detail about it. I'm just kind of explaining the concepts that Sharp provides. So, what is the catalyst to building this language? So kind of what made me kind of want to build this language? Because I've been told several times that I'm crazy. There's already tons of languages out there. I'm really smart. I can use my knowledge for other things, such as, building some application that does some magical thing that would change a lot of people's lives. But I actually believe that as programmers, we struggle a lot when it comes to this battle between high level and low level. And when I started programming, that was the first time that I experienced this as an actual issue. You can see here that there's a simple Raspberry Pi with some GPIO pins, and it's probably turning on some LED. Didn't get the full picture. But when I started programming, I started with the Raspberry Pi. When it first came out, I thought it was really cool, and my dad got it for me, and I wanted to kind of just use it and see what I could do with it. And of course, I did the simple stuff. So I just did simple Hello World program. I did a simple calculator program where you typed in some numbers and it added some values or something like that. But then I wanted to get a little deeper. I'm a very inquisitive person and I like to tinker and figure things out. So I wanted to really start to understand how this computer worked as a whole. Like, why is it so tiny? How does the GPIO pins work? How can I, turn on the LED, do some form of low-level functionality? And at the time, I couldn't do it in Java. Java didn't support it. And I didn't want to turn to C++ because C++ was very scary at the time. But then also at the same time, I didn't really want to go to Python because, one, Python was a bit slow, and I kind of wanted something a little bit more high level, because up until that point, the first language that I actually learned was JavaScript. And then after JavaScript, I learned Java. So it was more natural to me to learn and use, a high-level object-oriented programming language. So this kind of brought me on a quest to basically have to force myself to learn C++ in order to do all the low-level stuff I wanted to do. I wanted to make a robot. I made a robot and did some stuff with a servo and used the GPIO pins to control the wheels and stuff like that. I also did some applications where I did my own Wi-Fi processing, so I was sending a signal from one Wi-Fi device to another and some other stuff like that. But the general problem was that I had to turn to C++ to do this stuff. And I didn't really like that. So that was a little bit of a tangent. Kind of wanted to explain my background to how this language came to be. And now I want to get into what are some of the other benefits that this language provides. So I know some of you have probably already rolled your eyes about it being an object-oriented programming language and saying this is just another pain in the butt, that it's going to take a bunch of lines of code to do something very simple. That's not the case. This language, I have some benefits, some of which are resource management. So right now you kind of have this thing where even in Java, if you have an object and you create a file and you're putting some data into that file, you always have to close the file. But what happens if you don't close the file? Well, you're going to have file descriptors, hanging around and stuff like that. Or also, what if you are doing some type of resource management where you have a bunch of mutexes, and let's say your thread has about 5 different mutexes that it has access to, and then all of a sudden you exit out of the thread. But in your code, you forgot that that thread was actually holding references to all of those mutexes. So now what happens when another thread comes and tries to access those mutexes? Essentially, you're going to get a thread deadlock exception, because the thread that is trying to access it is trying to access a mutex that is going to be held forever, because the thread that was holding it is now dead. In Sharp, you don't really have to worry about that. That's one of the benefits, where if you have a file and you don't close it, perfectly fine. You just don't send the data to the file. It's perfectly safe. You don't really have to worry about that. Also, if you have, and these are just examples, this isn't everything that the language is going to do. I'm just expressing some of the ideas and concepts that the language is going to provide. So let's say you have a thread that, in our mutex example, where you have all of those mutexes that are being referenced, and the thread just quits. When the thread quits, what the underlying system is going to see is that, oh, this thread has access to 5 different mutexes. We need to release those, because that's going to screw up any other threads that are trying to access it. So any major resource that you're going to be modifying and manipulating in Sharp, you don't really have to worry about this dirty code of it just not really working and leaving your application state in some weird state or something like that. Also, you don't have to worry about double freeze, as I mentioned earlier. Sharp is going to allow for malloc and free, but it's going to be completely safe. If you free multiple times on a single object, it's going to free that object, and it's going to be essentially the same thing as saying some data is equal to null, and it's going to take the reference before it set it to null, and it's going to actually free it. Now, one could argue, well, what happens if you have a class that has another reference in another class and you call free on it? What it's going to do is free is going to check to see, does this object have only one reference? If it has only one reference, i.e., let's say this variable declaration, if we only have one reference to this variable array or this integer array, then it's completely safe to free it. So all we're going to do is, behind the scenes, we're going to say some data is equal to null, and then we're going to free up that in memory, and then by the time the user gets out of this free function, if they try to use some data right after that, it's going to be set to null. So you don't have to worry about setting it to null, kind of like how you do in other languages, especially in C++. And I've had countless problems where I've freed data and not set it to null, and I'm still pointing to an invalid pointer. So that's one of the benefits that you get. Another benefit is, of course, as I mentioned before, invalid access to freed memory. But then also you get a dynamically typed language. The problem is that I don't have an example from before, but I'm sure you can all assume that, okay, well, that's cool. You have this object-oriented programming language. It has these concepts that are really nice and really convenient, but you still are going to have a statically typed language, or I'm sure you're probably asking, is my language going to be statically typed? Yes, it is a statically typed language, but it does offer the option to be dynamically typed, to where you don't really have to care about the type. So in this case, we can say, I don't care what type it is, so you use the question mark, and you just give it a variable name, and you just pass whatever you want into that function, and if it's an object and it has the function called name, then that gets called. If it doesn't, then you'll get an exception, saying that, this isn't an object, obviously. But that provides even more benefits in my language, to be able to not have to be bogged down by worrying about this whole concept of, oh, I have to remember what type it is. And no, you just have a function, you have some args, you don't really care about what the type is, but you know that the type that you're passing in is going to have some field called X or some function called name, and you just call it, or you set it or access it on that object. So you don't really have to care. So going forward then, what are the big goals for this language? And also, what's in it for me? And by what I mean by me, I mean what's in it for you. So, of course, you have the benefits that I expressed above or before. So, of course, you're going to have a dynamic and flexible language that's easy to use. It's object-oriented programming. but it's going to have C++ level of performance. And some other benefits that are kind of my big goals with this language is that whenever you're developing a language, especially an object-oriented programming language, it's really hard to debug some issues, like if you have memory leaks and stuff like that, and you'll see a problem, and then you'll say, okay, I need to change this, but then you'll have to make that change and wait for your code to recompile again, and then after it recompiles, you have to wait for the program to run and get up to a certain point, and then, okay, now I can see, what the difference is. In my language, I don't want you to have to do that. One of my biggest goals with this language, aside of course, speed and memory management and stuff like that, is I want there to be a much faster overall time that it takes for you to get your program or your application or what have you out to production. So, of course, you're going to have faster testing, which is going to bring your product to production ready. And that's going to also improve in compile times, because if you can just edit your code as you're kind of doing it on the fly, as you're debugging, you don't really have to wait too long for it to recompile everything, because it's kind of running in sync with your runtime system. And then finally, I also want to emphasize simple design, because it doesn't matter. At the end of the day, it doesn't matter what your language does. If you have a ridiculously complicated language that, although the benefits may be huge, simplicity is very important, especially nowadays. People don't want to write 10 lines of code to do one thing that can take one line of code in another language. So that's definitely an important aspect of my language. And I also want to allow for my language to be able to stretch from both ends of the spectrum, so from hot to cold. What do I mean by that? Basically, whenever you have a language like Python, it's very, very high level. And yes, it is nice. Now, it may seem like I am contradicting myself from what I said earlier. I kind of want to run away from C++ as fast as possible. I do, but there are some times, some situations where I really just want to do something really low level. I want to call malloc, I want to call free, do my own memory management. I want to realloc. So instead of, creating a new array and then copying everything by doing a memory copy and something like that, I can just realloc directly on that memory object and expand it, so that way I don't have to worry about that. And then you also have the other side of the spectrum where, you have your lambda expressions and stuff like that. Of course, Sharp is going to support things like lambda expressions, nesting functions inside of functions to be very expressive and functional. And that really makes the language much easier to use and a much more fun language to program in, because you almost, in a sense, can kind of do whatever you want and switch from being a low-level programmer to a high-level programmer simultaneously in the same language without really having to sacrifice much of anything, really, in terms of speed or quality of programming, because you have to now all of a sudden, if you want to do something low level, you have to do all of these things to make sure you check things in an appropriate way, so that way you don't make some mistake. So what are some of the smaller goals that my language has? I'm still building on them, but this is a start for the list. So first, I'm going to have, of course, like I said before, expressive coding aspects. So you'll have nested functions and so on. And then also I want to have helpful error messages in both the compiler and the runtime. So this is an example that I took. It was a snippet. This is actually from my compiler. Sharp is compiled by itself, so the actual compiler is written in Sharp, and Sharp compiles itself and then runs. But mainly what I want to show you from this example is that when you have an exception, typically the thing that I don't like with exceptions is that when you get them in a language, it shows you, where the line is, what the function is. I get that, but it would just be easier if you could just look directly in the console and say, oh, This is exactly where the error happened. Let me look there. I understand that it says the line number there, but it's even faster to physically see what led up to this crash and what did you do that maybe could have invoked the crash to happen. So this is just one of those examples that kind of shows that. Oh yeah, so we forgot to talk about performance. So performance is one thing that's always looming in the back of everyone's head. Now, for all of you benchmarking trolls or quote-unquote real programmers or people who have been in the industry for many years and are going to say that this isn't really a real use case or a real test case, this is just for potential. This is showing potential of the language, not so more of me bashing Java. So in this example, you can kind of see I just did something very rudimentary, very simple. It's just a simple for loop with iterating through a for loop a bunch of times, and I ran it in Sharp, and then I also ran it in Java. In Java, as you can see here, it took about 257 milliseconds, and in Sharp, it took about 37 milliseconds. If you want to say technically it didn't, it took 64, okay, you can say that. But that's still more than twice the speed of Java in this rudimentary example. Now, again, this is very simple. Things could change depending on what I do, whether I'm doing some I/O or something like that, but this just shows the potential for Sharp. And to put it in context, C++, I don't have a snippet here for it, but I did run a test for C++ doing the same thing, and C++ took 25 milliseconds. Now, to be fair, this was unoptimized C++. When you optimize it, to be honest, I don't even think C++ runs this function because it literally does nothing. So I think C++ just omits this function and it takes like 2 milliseconds to run. I could be wrong. I'm sure you guys will correct me for that. But just to put it in context, that unoptimized regular C++ took 25 milliseconds and my Sharp example took 37. So I'm fairly close to C++ level of performance. I'm not going to be exactly there, but this definitely shows the potential on where Sharp is going and where it can go. So that's pretty much it. I also want to do a final kind of exiting for this. I know you guys have been listening to me for a while. Hopefully I didn't put anyone to sleep. But the final thing that I want to show you guys is my repository. So I've done it before in a video before, but now Sharp is becoming a language that is starting to be really hard to manage. So kind of let me reiterate you guys on why I decided to make this video. I haven't really been putting out too many videos because Sharp is now become something that I'm sure you can all imagine based on my talk. It's a lot of work. And I don't really have time to do anything else because I have to do this. I have a full-time job. I have, a life outside of this. I have to do other things but other than programming. So I don't really have too much time to do YouTube videos. However, I do plan to, going forward, do YouTube videos, but they're going to be in a different style. So I know that I kind of started with doing how to build a programming language. I'm still going to show you guys how to build a programming language, but it's going to be a little bit different. So I know that it is bad for you to kind of say, let me show you how to make a cake. Okay, here's the cake. Let me just explain to you, let me cut it in half and explain to you how I kind of built it. I understand that can be kind of difficult, but I don't really have too much of a choice in making the time for doing this and doing everything else. So I hope that you guys can understand that and still stick with me in this YouTube series and showing you kind of how the inner workings work and going through all of my different libraries and files to show you kind of how I built this compiler as a whole. And I also want to kind of get help from you guys. This programming language is a ton of work. I've been actually working on this language for about 4 years now. This is a new repository. So I used to work on a language previous to this, which was called Scorpion, and it was a very bad language that didn't really have a true direction. I feel that Sharp was a lot better. So I'm looking for you guys to, one, if it would be possible for you to star my repository. That helps out a lot, and fork it, because that's going to show that, you know, people are interested in my language. And I also want to get, of course, syntax highlighting on my language for Sharp. So I have, you know, in here tons of files that is basically the Sharp standard library, but they're not syntax highlighted. And I was also looking for some people to help manage this, because as I've been building this language, I've had to crank out thousands of lines of code a month just to kind of get this language stable and to keep it stable and to keep it working. But I don't really have time to do too much testing on too many things, if you can imagine. It's just me working on the language. So if any of you were out there that would be interested in helping out on this language, that would be a huge help for me. You can go to my repository and fork it and send a pull request with, you know, some suggestions and things like that. I also have documentation here that if you guys are interested in reading it, it is a bit out of date, but it's relatively in line with what Sharp is in terms of today. So that was it. I hope you guys enjoyed the video. Definitely like and subscribe if you guys like what you saw and you want to see more. Until next time, see you guys later.